During college life, he was president of SAE Collegiate Club. He has a vast experience in robotic and drone technology. Presently, he is working in various drone R&D based projects. He has been resigned from Vivo company and started his own startup in the name of Indian Defence Reform Company. So, Vyom Ranjan Singh has a vast experience and having also started a startup. So, his experience and his talk surely help us for a new to know about the new technology about the robotics and drone technology. So I request Vyom Ranjan Singh, sir, please start your speech.
Okay, thank you, sir, for that kind description and kind background about me. Okay, so now I'll present my screen and start the presentation here.
Okay, sir. Okay.
Okay, sir, I hope everyone can see this presentation.
Yes, your slide is looking. No.
Okay. So first of all, I would like to thank the Institute for having me to talk about the drone technology. And I would personally like to thank Chandan, sir, for being my mentor and guiding me through my career life. Okay, so I am basically co-founder, as sir said, I am basically co-founder of and technical head of Idea Technologies, and we try to build drones in India for India. Okay, so I'll start with what are the basics of drone technology and how we can classify and define drones. So, in general terms, the most widely accepted definition of drone is anything that can be controlled remotely or operates autonomously. Okay, so that can lead anywhere from RC planes, as you can see on the left hand side image, from RC boats to RC submarines to RC multi rotors as well. But according to official sources, drone is also known as UAV. So we will just go with that definition, and we will just use the drone terminology to bind it to anything that flies. Okay, so the two things that flies are both multi-rotor as well as fixed wings. Okay, so multi-rotors both have their own advantages and both have their own disadvantages as well. In the case of multi-rotor, we have a limited flight ceiling of around 500 meters, and I'm talking about any standard drone here, standard size drone, and the flight time is very limited because when a multi-rotor is in air, the propellers are producing the thrust and propellers are producing the lift that is keeping the whole mass into air. That is why we have a very limited flight time, and of course with limited flight time come a very limited range as well. But on the other spectrum, we have a fixed wing, and a fixed wing, of course, is a plane which has a much greater flying height ceiling of up to 1000 meters. It can go up depending on your radio connection. Of course, the flight time is also increased by 50 to 60 minutes because unlike multi-rotors, once fixed wings are in the air, the wings are producing the thrust and not the propellers. And of course, in a fixed wing, we have one or two motors as compared to multi-rotors, which requires more motors depending on the payload. And with a high amount of flight time, the range is also increased. But multi-rotors are cheap to build, easier to operate because they can navigate autonomously. We can implement autonomy on both the multi-rotor and fixed wing, but it is easier to implement on multi-rotors. Of course, they have a very easy vertical and takeoff landing VTOL system, so they can operate in areas with lot of trees and lot of, of course, in urban areas as well. They are suitable for local mapping because we have a much greater degree of control on multi-rotors, and of course they comply with aviation regulations because of large number of drones. It is the first thing that government is trying to put rules upon. On the other hand, fixed wing are expensive. They need experienced operators. They do not have horizontal landing and needs a large amount of space for takeoff and landing. But of course, they cover large distances. Now, there exists planes, of course, as you know, that combines both of these features of multi-rotor and fixed wing, which we call VTOL, vertical takeoff and landing aircraft. The best example I think is of Osprey V-22 aircraft or American aircraft, and of course F-35 Lightning, newly developed aircraft by Americans, generation fifth fighter aircraft. Now they can, of course, take off and land vertically, but once they are in the air, they can convert into a fixed wing. So the wings is generating lift now. Now some of the earlier developments which pioneered the way for VTOL aircraft, of course, is Lewis. In 1908, he developed the first four propeller design, which we now call quadcopter. But since it was a very early prototype, it was a tethered flight. On the other hand, Eaton experimented with rotorcraft design in 1920s, and among the designs, he tried 4 rotors and 8 propellers. 4 was mounted on top and 2 was at the bottom, driven by a single engine. Now we come to the pre-modern era of drones, 1980 to 2000, in which the industrial drones took a major leap, and we started seeing companies like Bell, Boeing, and Airbus compete for development of drones on a very large but on a military-oriented scale. Now these companies, Bell, Boeing, and Airbus, of course, drone has many categories, weight categories. Now these companies develop the drone in the heavy category, of course, and they are usually fixed-wing aircrafts and used by military like Predator drones, etc. On the other hand, companies like GoPro and DJI, they focus more towards consumer drones. Okay, so drones that are in standard or mini or micro scale, and they are usually used for mapping or mapping an area or for videography, photography, and of course the implementations are many in those cases. We at IDR, we have developed this company in order to make a drone for India. Okay, so we want to make a completely made in India drone for Indian consumers and of course for Indian armed forces. Now, future of drone technology. Now, along with manual control, implementing various useful features from autopilot and AI will pave a whole new and wider path for implementation of drones. We are in 2021 right now, and as we are getting more and more powerful ICs being manufactured, packing more functionalities and processing power into a smaller space, we will be getting AI, faster learning AI, deep AI in drones very fast. Okay, so consumer drones needs increase as the understanding of usefulness increases and the cost decreases. So that is why we are also trying to get Indian consumers for drones, because DJI and other companies that make robust drones are very, very costly here in India. On the other hand, militaries of countries compete with each other to get cutting edge in drone technology to always have the upper hand. Okay, so of course the drone technology, it goes without saying that the growth in the drone technology is growing exponential. In 2015, it was valued at 335 million US dollars, and as you can see here, in 2021, it is over 1,000 million US dollars, and it is going to expand. And of course, the 3 categories that I have shown here is prosumer, toy or hobbyist, DIY, or photogrammetry used on the drones. Of course, you have to get an idea of how unsaturated the field is up until now as well, because government in various countries have not even made proper laws about drone flying and of course manufacturing of drones. So it is a very unsaturated concept, and there are very, very grand research opportunities. I will be talking about research opportunities in drones as well, and what research we are doing at IDEA when it comes to drone. So this is basically the most basic drone that we can make as a hobbyist, as a professional, or as a researcher. So this is basic from a researcher's point of view. This is basically the main starting point or base of a drone that you can build to get flying, get the feel of how drones flies, properly maintain it, align it, and according to that you can add more features on the drone in order to get your research done. So of course there is a transmitter. Of course you can use a manual transmitter, or you can program set of commands, or you can use onboard sensors to make it autonomous. Now the transmitter sends the signal to receiver, and the receiver sends the signal to flight controller. Now the flight controller is the main brain of a drone, and they are commercially available. You can of course make one yourself using a microcontroller like 80 mega used on Arduino board. The flight controller in turns sends the, let's talk about quadcopter where we have four motors. The now the four motors are connected by in turns by four ESC, which are electronic speed controller. Now these are electronic devices that controls the individual RPMs of the four motors. Now what the function of the flight controller is, it sends the signal to the electronic speed controller and tells the speed controller to set the motor at a set RPM, so that it produces a set amount of thrust, and which in turn balances the quadcopter in air. Now the power to both flight controller and ESC or electronic speed controller is given by usually traditionally a LiPo battery, which is distributes the power using a proper power distribution system. Now we use a proper power distribution system because if we connect the wires directly, it can cause interference in the signal, because flight controller have a very sensitive equipment on board like barometer or compass, which can be disrupted by electromagnetic fields. Okay, so along with the basics of drone, everything else according to the requirement can be added. As I said before, you can add a video camera to get a live video feed, and of course add a DVR. That is the very basic function of what industrial drones do right now for photogrammetry, videography, picture capturing, etc. We can add GPS for increased functionality, machine vision, AI, autopilot, navigation, and of course various sensors to measure physical parameters based on research need. Now the examples here where you need to measure physical parameters like temperature, humidity. You need to measure temperature, humidity in area where it is very dangerous for humans to be, like near an active volcano, or in a cave with high amount of deadly gas. Okay, so you can send a drone there or a rover there in order to collect the data. That is why it is important to make a drone and implement it in your research. Now, of course, drones are also used for weapons by the military, like predator drones or etc., in which the missiles or other weapons are mounted. Now this is the main classification of drones. Now this is the classification based on which the governments of various countries are regulating the drones. So now first we have the nano range, which is less than 50 grams. It is a very small drone. It can either be a toy, or it can either be a very professional drone worth $60,000. As you can see in the center of your screen, a helicopter-like design, which is being developed and used by many militaries around the world. Then there is a micro category from 100 to 250 grams. Then there is a mini category. Then there is a standard category. The standard category drone, as you can see in the center of the screen's example, I've taken as Phantom DJI Phantom drone. This is the very basic type of drone that is used by every photographer, videographer in our country. Then we have heavy drones, which can be using multiple motors, multiple propellers, as you can see in the bottom right hand side. And then we have biomimetic type of drones, which basically mimics the nature around us. As you can see, a drone that can mimic a bird or a butterfly, or just a bird or a butterfly, etc. So this is basically the classification of drones on base of their sizes. Okay, so now I will talk about the flight controller. Okay, I will go from each and every component, how we can implement it, what are the research benefits, and how we can research it, of course. Now, the basics of a flight controller, of course, I have classified a flight controller into three categories, and all of these categories have their own research opportunities as well as their uses. Okay, so first one is a basic hobby style flight controller. The on the first flight controller you can see with an LCD attached. Since it has an LCD attached, you can program it. You do not have to connect it to your computer. You can program it on the flight controller itself. This flight controller's name is KK Flight Controller, one of the oldest companies, one of the oldest flight controller out there, and it is a very robust flight controller because it has years of development behind it. But the disadvantage here stands that it is flight controller for beginners. You cannot alter the program that is already been rewritten. Since you cannot connect it to a computer, so it is very limited to what it can do. On the other hand, we have programmable flight controllers. Okay, these are the intermediate type flight controllers and offers much control and customization option. On the bottom right hand side, you can see an F3 based flight controller, SP Racing F3, and it has a mini USB slot. So it can be connected to a computer, and you can program that flight controller based on based on what type of multi-rotor you want to build. Okay. Then we have an autopilot flight controller. These are the cutting edge in both research field and making robot drones. For example, Pixop. This is basically a complete package. It involves a flight controller. It has a GPS system inbuilt. It has compass, barometer. It has everything that a flight controller, proper drone needs for research for options. Of course, when we come to programming flight controller, when we connect the programmable flight controller and both the autopilot flight controller to the computer, we can use these softwares to program them. I personally used to beta flight and plain flight. These are open source programmers. They offer both very beautiful graphical user interface, so it is easy for beginners. Plus, they have a command interface as well. So the more experienced programmer can go into the deep of the code and program custom programs in order to upload them to the flight controllers. Okay, I will explain how that works further in the slides. Of course, there is LibraPilot. LibraPilot is a very old version, now outdated. INAV, and of course APM Mission Planner. APM Mission Planner is used with APM type flight controllers and Pixop because it has a GPS. It has a GPS, comes with the flight controller. Then it can plan a mission and make the drone go from point to point autonomously. You can plan that on your computer. Now these are some research field and what we are doing in a flight controller. This is an FO based flight controller, which is relatively new, and as you can see, the three main processing chips on the center of the screen, you can see it may look intimidating, but it is a very simple concept of flight controller. It basically is a main processing chip, STM based, ARM based, or 80 Mega 2650, the same chip that Arduino Mega use, and this is the main processing chip. And of course, we have an accelerometer and gyro chip. Then there is a crystal oscillator for the processor. Then there is a compass, barometer, and in newer type of flight controllers there is inbuilt GPS as well. And everything else you see, capacitors, resistors, diodes, all are complementary, and it comes how to wire them in the main processing chips and accelerometer and gyro chips data sheet. Okay, so as for the functionality of the when we talk about commercial flight controllers, as when the functionality of the flight controller increases, it goes from F3, F4, and F7, just like Intel processors. First we have i3 Intel processor, then we have i5, and then i7. So in this case, it goes from F3, which is the oldest, that I think it came in 2013 or older. Then F4, which comes in around 2017, and now we have the latest F7 generation flight controllers. These basically goes to show that how the main processing chip and the accelerometer and gyro is developing. Okay, in order to go further research on microcontroller, of course it is being done, and you can research on decreasing the weight of the flight controller, since the weight plays a very vital role in any type of multi-rotor. As the weight increases, the propellers have to, of course, create less amount of thrust to keep the multi-rotor in the air. Of course, when we are building when we are building customized drones, the PCB of the flight controller must be customized to the drone. So that is, of course, another research opportunity. So we at IDEA researching, we are of course assembling our own flight controller, because most of the flight controllers, or almost all of the flight controllers, are built, manufactured, assembled, designed, and then shipped to India, and then are being used as both in hobbyist and commercial drones. So of course, we cannot do anything about building our own processing chip or accelerometer and gyro chip, but everything else is made in India. So basically, we are trying to assemble a fully completed flight controller in India for an Indian drone. Now, when we choose a type of flight controller, now as I said, the advantage of choosing programmable and autopilot flight controller is that you can choose a configuration. Of course, it is also available in KK type microcontroller, but we can get a more exotic range of configurations when we choose programmable flight controllers. Okay, now configuration is nothing but number of propellers and number of motors. A tricopter has 3 propellers and 3 motors. A quadcopter X has of course 4, and quadcopter plus also has 4s. The difference is only that in quadcopter X it is an X when we fly it forward. It is an X configuration, while the other one plus. We have hexacopters, octocopters, multiple propellers. Okay, so these are configurations we can choose from. Now, when you are building your own quadcopter or any type of multi-rotor, for the sake of argument, let's say that you are trying to build your own quadcopter, you have many things to consider. Now, the first thing is that you are not buying a team. There are many type of frames. The frame is something that you build your quadcopter on. Okay, there are commercial frames available, but when you are building your own frame, there are things to consider. Of course, first thing is CG of any flying object matters, and thus it matters in this case as well. You have to get the CG right. You have to get the CG right in between the same distance from each of the force generating point or motors as mounted. So making sure that each of the force generation point or the motors are mounted at the same distance from the CG. So in order to do that, I would recommend that utilize most heavy objects on board to balance out the CG. And the most heavy object is of course the battery. So you can adjust the battery according to where the CG should be, and of course where the CG lies, you have to mount the flight controller right on top of that CG center of gravity. Okay, so this is one of the tips that I personally use in designing only. So when you are designing your quadcopter, you have to keep that in mind. Of course, one may think that since it is a quadcopter and propellers are producing most of the lift, aerodynamics is not important, but aerodynamics plays a very important role. Not because we have to generate lift, because we have to reduce drag. So in order to reduce drag, of course, we need very low amount of surface area. So of course, we have to keep aerodynamics in mind to build a very efficient frame. Of course, rigidity is very, very important. There should be no flex at all in the frame. And of course, keep in mind the power to weight ratio. You have to remember how much thrust each of the motor can generate, so you do not make it underpowered or overpowered drone. So this is basically the overview of the things you have to concern. There are of course plethora of things that you have to actually consider while designing a drone, but this is basically the overview and key points of things to consider. Now there are many fields of research in frame. Of course, you can research lightweight material and with enough strength to build a frame with. Nowadays we are using carbon fiber or aircraft grade aluminum frames. Okay, so of course materials can be developed for drones which are more lightweight and have enough strength. Now, designing a frame optimized for the situation, this is a very, very important concept. Okay, so best example I can give you again is of DJI Mavic. As you can see on the bottom left hand side is a Mavic series drone, and it is foldable. It can fold itself for ease of storage. Okay, fold itself for ease of storage. So it is a very consumer friendly drone because drone usually have rigid arms and they can break off in transportation. So for ease of storage, it can fold itself. On the other hand, on the right hand side, you can see Inspired series of DJI drone. Now, what this drone does is once it is in the air, you can see there is a line, there is a carbon fiber rod connecting the body to the arms or propeller mounted arms of the drone. Once it is in the air, actuator actually lifts up the arms so that the propeller are above the camera. And once that is done, the camera gets a 360-degree view of the surrounding. So one of the biggest advantages of a drone is that it tilts forward when it is flying forward or in any direction it is going. So if the camera is facing forward and the drone is going forward, there is a high chance that propellers will show up in the image of the camera. So this completely eliminates the problem by just lifting the propellers up and out of the view range of a camera. Okay, so this is very important concept that you have to design a frame optimized for the situation. Now, of course, let's move on to the motors. Now, traditionally, motors, the two types of motor that is used on drones are DC or BLDC. Now, both have their advantages and disadvantages. But DC motors are incredibly inefficient. Of course, they are very difficult to control. Of course, they are very difficult to control the RPM of in drones. Although they are used in micro drones, the toy drones which are in the micro category. Of course, they use these DC coreless DC motors for the sake of simplicity, but they are simply not robust enough for a standard or a mini sized drone because, and of course, it should have said there, but they are also not powerful enough for a standard or micro sized drones. On the other hand, we have the BLDC motor. The full form here stands for brushless DC motors, and they are the most widely used motors when it comes to drones. Of course, there are advantages over DC, that is why they are most widely used. They have a high torque to weight ratio, they have increased efficiency, producing more torque per watt, they have increased reliability, they have reduced noise, and of course, they have longer lifetime by eliminating the brush and commutator erosion. So that is why BLDC motors are used, and of course, they are also completely waterproof since they have no brushes. And they work underwater as well. Now, there are many, of course, research options in drones. The motors itself, unfortunately, brushless DC motors that are used on drones, there is no company as of yet in India that manufactures them. And so most of the motors are being imported from China. Not most, almost 99, not almost, yes, almost most, 90% of these motors are imported from China. And of course, China is still researching and improving efficiency of these motors, and it is still being researched upon. But of course, as you can see, there are many options, research options in the motor as well, that can be improved as well. Okay, so this is about the motors that are used on drones. Now we come to electronic speed controller or the ESC. Now this is very important electronic component of a drone. It basically converts the DC power from a battery. The LiPo battery that we have to power the drone supplies the DC voltage. Okay, but the BLDC motor that we utilize, as you can see, since it is connected in a star connection, it utilizes three-phase power. So in order to convert that, ESC or electronic speed controller is used, and it not only does that, it also converts the RPM of a motor. And in order to do that, it basically generates and syncs the voltage of the three wires in star connection in motor in order to rotate it at a specified RPM. Now, here is what an ESC looks like, and these are the wires, basically the important wires of the ESC. Now, as you can see, of course, on the top hand side, there is a ground wire and a positive wire on which the battery is connected, and on the other side, we have the three wires for the three phase. three phase of the motor. And on the input side there is of course another two wires, of course a ground wire and a signal wire. Now the signal wire is what plugs into the flight controller, and the flight controller sends a signal on the signal PWM signal wire, based on which the ESC decodes the message and sets the RPM for the sets an RPM for the motor. So this is the PWM signal that the flight controller sends to the ESC. Now the duration time, or the length between two pulses is set at 20 millisecond, but in standard ESC or standard market ESC. But the duty time cycles varies from 1 millisecond to 2 millisecond, which is the pulse width, based on which the ESC sends the power to the motor. For example, if the flight controller is sending a pulse of 1 millisecond, the flight controller, the ESC will power the motor at lowest RPM, and if the flight controller is sending 2 millisecond pulse width, the ESC will power the motor at highest throttle. And of course, it can vary, since it is an analog signal. It can vary the pulse width, and based on which the ESC will power the motor. Okay, so of course there are again many research options in ESC which we are currently looking into. You can change the pulse duration PWM signal to increase control and accuracy. Of course, when we have a powerful ESC or a powerful microcontroller on board, we can decrease the duration time and control the motor. We can decrease the response time and control the motor very efficiently, making the circuit of course more efficient, and decrease weight. Decreasing weight is of course a major factor in any case when it comes to multi-rotors. Since ESC is since it is converting power, it gets the ESC is something that gets that generates a lot of heat. Of course, it is not good for any type of electronics to generate heat, which means it is converting some of the energy into heat. But proper heat dissipation, nevertheless, some heat will be generated, and a proper heat dissipation method is very important. So any type of heat dissipation method, whether it will be liquid cooled or air cooled using heat sinks, etc. Adding more customization and safety options. Right now the ESC looks like this. Okay, there is research being done in order to make the ESC more customizable. For example, currently most of the standard ESC market does not have protective protections over it, like overcurrent protection, temperature protection, as well as current limit setting by users. These are some things that needs to be researched upon and improved in when it comes to ESC. Now we come to transmitter and receiver system. Usually we utilize a 2.4 gigahertz transmitter system, which gets a proper and solid connection. So in order to, of course, we use 2.4 gigahertz because it is allowed by the government. Other bands like 1.3 gigahertz is of course restricted by the government. So we use 2.4 gigahertz system in order to achieve that. In order to achieve that, of course, a microcontroller reads the value using a communication protocol, either I2C or SPI, in order to send it to a modulator, and which in turn sends the data to a receiver via an antenna. So you can see here is a flow chart of what happens. First, of course, there is a physical value reader like a potentiometer or switch. By potentiometer, I mean here joysticks. So we usually use joysticks to control a drone. Now these reads the physical changes, and they send the value over to microcontroller. Now the microcontroller itself, of course, does all the mapping of the values and sends it to a modulator. The modulator itself sends the signal via the antenna to a demodulator receiver, and the signal is received by the flight controller. So that is how the transmitter and receiver system works. Now, in order to transmit a signal from microcontroller to modulator, we use a series of communication protocols, either as I2C or SPI type communication protocol. Now, I2C is not currently being used in these types of situations, but of course, it is a very simple type of communication protocol. We have a master, which is a microcontroller, and it is connected by two pins, SDA and SCL, which is serial data line and clock line, and we have some pull-up resistors, so the signal can be pulled up to 5 volts. So of course we have multiple slaves, and by slave I mean a modulator or a receiver module or a transmitter module. Sorry. Now this we can of course connect multiple transmitter modules, but for in this case we can just connect a transmitter module on the SDN serial clock line, and that's how they communicate. On the other hand, we have the SPI. Now this is the type of communication protocol that almost all of these transmitter and receiver system use. Of course, there is again a clock line because every microcontroller needs a clock line. There is a MOSI and MISO, which stands for master out, slave in, and master in, slave out. Both of these communication use master and slave type communication. Master, of course, stands for the microcontroller, and slave is the transmitter or modulator itself. Now master out, slave in, master and slave out, these are the communication line between master and slave. So basically here master microcontroller sending data to the slave, like potentiometer values and switches values, and the slave itself is sending data to master like acknowledgement, like the data is sent, acknowledgement is sent back to the master, so we know that the data has been sent, and we can get control out of it. And the fourth pin, of course, is slave select pin. If you have multiple slaves or if you have multiple transmitter modules on the same line, so we can select them using slave select pins. Now, of course, there is much research opportunities that are included with transmitter and receiver systems. Some are being done by us as well. First of all is hardware optimization for fast and reliable data sending. So it is very important to send a to have a solid connection between transmitter and receiver. If the data packets are lost between the transmitter and receiver, even for say 20 milliseconds, so it can mean the difference between crashing of a drone and surviving of a drone. So we have to get a very reliable and solid connection. So that is why, as you can see on the third point, getting a stable and reliable connection between transmitter and receiver. We currently are using multiple transmitter on different antennas and using them the one of them which have the best signal. On the other hand, as you can see, the most of the microcontroller like that we use, like 80 mega 328, have a limited amount of analog channels. It is limited. I think it is limited to 7 analog channels, and we cannot add more analog channels, but we can do that using multiplexing analog channels. Okay, so of course we are researching on this thing in order to add multiple analog channels, so we can get more control out of the drone. And then we have the FPV system. Now FPV stands for first person view. It is a very simple system. As you can see, the camera on the right hand side, on the left hand side, you can see camera which captures the image, and it is powered by a LiPo battery, and it transmits the image using a 5.8 gigahertz. This is the frequency that is currently being used. That is currently not being regulated by the government. It is free to use frequency. So using 5.8 gigahertz video transmitter, it is sent over to a receiver, and of course the receiver itself decodes the video transmission and displays it on the monitor. And we can add a DVR or digital video recorder in the system as well, so that everything is recorded. Now there are many research opportunities on this as well. Currently we are trying to use 1.3 gigahertz or 2.4 gigahertz channels to increase connection qualities. Since the frequency increases, the penetration of the waves also increases, and we can get a larger transmission distance, as well as we can get a proper signal even when the drone is flying within walls or in between trees. 5.8 gigahertz channel is very susceptible to noises from the environment. Now, of course, you have to be aware of some channels as they are banned by government guidelines. Uh, Video transmitter and video receiver again is something that gets very hot for a longer duration of time. And of course, heat dissipation again is very important for proper functioning of the as DJI is doing, we are going from analog video to digital video transmission system. This is a very, this again is a very unsaturated concept when it comes to research opportunities in wireless video transmission system. Again, using different antenna configuration to get better and stronger connection. As you can see on the bottom hand side, we have many types of antennas. Okay, so one type of antenna is cloverleaf antenna, or that otherwise known as omnidirectional dipole antenna. It basically gives a spherical range around the user. On the other hand, we have high gain directional antenna, like the satellite dishes that we have connecting our TV. So these basically gives a cone of visibility for video transmission. As you can see on the right hand side of the image, it acts like a flashlight. On the other hand, the omnidirectional antenna acts like a bulb. There are other types of antenna, of course, but these are the basic two types of antenna that we use. Of course, we are using both of these antennas you can use both of these antennas to get a better RGB image or a better signal for your video transmission system. Now the battery is probably the most important as well as the most dangerous part of a drone, because we need to implement a battery which can not only store a large amount of energy but also can supply the same if need be. Okay, so in case of a standard, these are the standards of a quadcopter, standard current consumptions. Okay, and by standard I mean a drone of around weight of around 800 to 1.2 kilograms. Now on takeoff, the current can peak up to 40 to 60 amps. At hover, current stabilizes at 20 to 35 amps. At cruise, current goes from 30 to 45 amps. And we are flying during fast flight or acrobatic flights, current goes from 500 to 100 amps up to 150 amps depending on the speed and weight of the drone. Now there are not enough. The standard battery cannot supply this much amount of current. It will of course explode if this much amount of current is pulled from it. So we need a battery to do that. So the best contender here, and it has been for a decade, is the LiPo battery, because it has a high discharge capacity and very high storage capacity, which means it has a high energy to weight ratio. So that is why we use LiPo batteries. Now some standards that you need to keep in mind. Of course, the battery has C rating and an mAh rating. mAh is milliamp hour, which means how much milliamps it can supply for 1 hour. This is basically determines the capacity of a battery. On the other hand, there is a C rating. Now C rating is multiplier to mAh for highest rated discharge. For example, as you can see image, there it is rated at 2200 mAh, which means 2.2 amps for 1 hour. This battery can supply 2.2 amps for 1 hour, but since it is rated at 40C, which means it can, when you multiply 40 from 2.2, that is the highest amount of current it is rated at. You can pull that much amount of current from this battery. So that is why LiPo is very important, because a quadcopter can easily pull 50 to 100 amps depending on what you're doing in air with that quadcopter. Now the battery itself is made up of number of cells. Here you can see it is a 3-cell battery, that is the S rating, 3S, which means it has 3 number of cells, and each cell usually has a nominal voltage of 3.2 volts. Of course, these are very dangerous. You have to be very careful while implementing these, as overcharging, over discharging or physical damage can cause the battery to explode. not exactly explode, but it can cause fire inside your drone if you overcharge or over discharge the battery. Uh, but the recent flight controllers or the power distribution board that you have on your flight controller comes with overcharge or over discharge protection. So when the battery goes down below a certain voltage, the quadcopter will automatically land, thus protecting it from a fire, potential fire hazard. Of course, recharging battery is already in full swing around the world to increase capacity, life cycle, and decrease the weight. Some prospect, of course, includes lithium ion. Lithium ion has more energy to weight ratio, but we are still using lithium ion, lithium polymer. The reason is very simple because, of course, it has a very high discharge capacity. Lithium ion still does not have the discharge capacity that we need in order to implement it on drones. But of course, it may change in 1 or 2 years based on the research. Then we are researching other research subjects, of course, include replacing the electrode in LiPo to increase the overall functionality and safety, like the Tesla is doing, changing different, experimenting with different elements in order to increase the safety and functionality rating of their battery. Okay, now these are some different sensors. Now we have made a basic drone. Now we can implement different sensors on the drone. First of all, of course, is the RGB camera, which is the video camera, which captures the image. And then is the LiDAR sensor. It provides a high definition 3D three-dimensional information of the surrounding and environment. If you mount this on a quadcopter, you make it autonomous with proper programming, so it can navigate its environment, whether it be urban navigation, forest navigation, or indoor navigation, etc. So there are two ways, of course, of doing this, either with LiDAR or multiple cameras and using AI. Then there are thermal sensors. Then the other two sensors, of course, are used on military drones as well as research drones widely. The thermal sensor, of course, is used to capture image, and from that image we can determine the temperature of the surrounding, uh, or the temperature of the surrounding, of course. And there is a multispectral camera which can capture image in multiple spectrums. Now some other components that are being mounted on a standard industrial drones, of course, are GPS. Now GPS is something that is very important along with proper flight controller, because it gives you many fail-safe features as well as many additional benefits of mounting a GPS. First of all, it gives you position hold. Now these three the three the three the three features that I have listed here are very standard in this industrial drones. The first one is position hold. When you turn on a digital switch on your manual transmitter, the command is sent to a flight controller. A GPS coordinate is recorded, and the motors are commanded, and of course the flight control is commanded to hold that position. And even if a wind comes or blows the drone from left or right, it basically it uses the GPS again to track the coordinates and fly back to the same position. Of course, there is a return to home mode. When you take off a flight controller, the GPS will record the coordinates, and at the flick of a switch, for example, when you are losing your transmitter connection or video connection, you just flick a digital switch and the drone will automatically return to the point where you launched the drone. And there is autonomous navigation. When it comes to environment, when it comes to LiDAR, when you are implementing LiDAR or multiple cameras on your drone to make it, and of course implementing AI to make it navigate the environment on its own, you need GPS as well to make it completely autonomous. Multiple cameras, of course, as I said, for obstacle detection and avoidance. Now this is basically of course there are many other functionalities of a GPS. Okay, so when for example implementation of failsafe, when the for example implementation of failsafe when the connection is lost between the transmitter and the receiver, the drone may hold that position, it may return to home, it may circle the position at which the last connection was lost. so that it can try to regain the connection with the transmitter system. So GPS again is very important. Now application is something that is limitless when it comes to drones. As I said before, applications include agriculture, and by agriculture I means monitoring the crops, spraying pesticides over the crops, etc. Delivery services. This is something that has been recently banned in India for some reasons, but it is an opportunity that the Amazon is trying to develop upon in order to use drones to deliver packages. Of course, military is using drones for many purposes as well. We have photogrammetry and analysis, basically taking pictures of an object from all angles in order to recreate it in a 3D environment. News and media, photography, videography, and of course, the biggest market, hobbyist and educational purposes of a drone. Now, there are many uses of drones in military and civil that I think we are trying at IDEA are trying to implement our drones for. First of all, military drones are of course used for search and destroy mission. Those are the big type of predator drones, and usually are fixed wing drones, not multi-rotors. We have reconnaissance mission, we have surveillance mission, anti-personnel mission. On the other hand, there are many civil applications of drones as well. We have policing, firefighting, search and rescue, disaster relief. These are the categories in which drones are actually being used right now. So it is very important to understand what drones are and how we can implement them. These are some of our most recent work that we are doing at IDEA. Of course, we were trying to make a tracked vehicle for mine detection for Indian Army. We have worked on quadcopter, bicopters designs as well. We are currently working on our own transmitter design. Currently, as you know, that there are almost all of the transmitter and receiver systems for a drone is being imported from China. So we are making a transmitter and receiver system for, of course, our Indian-made indigenous drone with an indigenous transmitter and receiver system. So it goes from designing to prototyping, and of course we are working on our own carbon fiber reinforced frame. With of course this is a very small frame for scout type of drone that we are trying to build. Thank you. If you have any questions, you can ask.
Yes, sir. Can I ask you a question?
If anyone have any query, they may ask.
Yes, sir. Am I audible, sir?
Yes, yes, your voice is coming.
So first of all, I would like to thank Vyom sir for nice presentation. Sir, only one concern in drone, as per my knowledge, the flight time and the speed. the two parameters. Actually, I want to how to control these two things. Means if I want to increase the flight time or I want to regulate the speed as per the requirement of different application. So
Yes.
what are the factors that I need to consider and how we can regulate this thing?
Yes. So when it comes to flight time, of course, it goes without saying, but one of the most important factors is weight. You decrease the weight, you increase the flight time. Of course, when since the weight is down, motor have to produce less amount of thrust. Then, of course, when you increase the flight time, you have to consider the quality of battery, ESC, electronic speed controller, and the motors of your motor you are using. The more efficient they are, the less amount of power they are consuming for motor and ESC. And on the other hand, the battery, the higher grade of lithium that the battery use or higher quality of the battery, the more efficiently it can deliver the power. On the other hand, when you're talking about speed of a drone, you have to consider the propeller. Okay, now propeller have two parameters. The first one is the diameter of the propeller, and second one is the pitch of the propeller. The higher the pitch of a propeller, the more power it consumes, but higher amount of thrust it generates. So when it comes to speed, I think propeller is the most important factor, and when it comes to increasing the flight time, the efficiency of the motor and ESC, as well as reducing the weight of the craft, is the most important factor.
Thank you, sir. Sir, actually, we were tested one drone, RC control, and at that time, what happened? It goes beyond the range of its receiver
Yes, sir.
controller. So I lost control and it goes far away from my place. So how to avoid this kind of situation, sir? Can you give some suggestion?
Yes, yes, sir. Of course. So the first suggestion is that flying out of line of sight is actually banned in India. So you cannot go out of sight with a drone unless you have a proper permission for it. But when you are flying out of line of sight, and when you're going a large amount of distance, the standard transmitter receiver system can theoretically transmit up to 1.2 kilometers. But in practical situations, due to humidity and other factors, the transmitting range is limited to I think around 500 to 750 meters only. So in that case, when the transmitter lose connection, as you can see on this on the slide I have opened right now, these are usually the programming software that everyone use for programming a flight controller. Or if you are using a KK flight controller, there is also an option called failsafe. Okay, so you have to program in the failsafe. If you lose connection, what happens is that the drone, you have to program it in such a way that the drone itself, uh, instead of going from full throttle to zero throttle and crashing to ground like a stone, it gradually reduces the throttle so it can easily land where the connection is lost. So that is something that I do in case I don't have GPS on my drone. If you have GPS, then all is well and good. You can program it to return to home. Otherwise, you can do that. The other thing that I was trying to do is of course again a research opportunity that we are doing to increase the range. If I can find it. Yes. So we are trying to get a stable connection by using multiple transmitter. So imagine you have multiple transmitter instead of just one transmitter, or instead of just one modulator, you have two modulators connected to a microcontroller, and each of them are using a different type of antenna. Okay, so one is using an omnidirectional dipole antenna, and other is using a high gain directional antenna. So once the aircraft is out of range for omnidirectional dipole antenna, you can point your transmitter, and you think you're losing the drone, you can just point your transmitter to a drone and use the high gain directional antenna. And of course, this high gain directional antenna has a range of up to 2.5 or 8, even 8 kilometers, depending on the gain of the antenna. and you will never lose a connection. So that is something we are trying to do. Switching between the antenna is again another game. We are trying to program the microcontroller such a way that it basically switches itself between the antennas when it detects which antenna has a better quality of connection. But again this is something that we are researching upon. Basically, you can do is program a failsafe or implement a GPS in your drone.
Thank you, sir. I would like to incorporate all these suggestions in future.
I see.
So I believe that there is no query from participant side, right? Okay. So
So I
thank
would
you,
like to
Vyom.
Yes,
It
sir.
was really very nice presentation.
Thank you,
And
sir.
on behalf of BIT SINDRI Department of Mechanical Engineering and Organizing team, I extend my heartfelt thanks to you. You are very
Thank you, sir.
dynamic, and I must say that the young youth must follow you as you have quit your job from Vivo. That was good, and you have started your startup, and you become
Yes, yes.
entrepreneur now, and you are making the dream of our honorable PM, make in India.
Yes, sir.
So it
Yes, sir.
gives
You have to
me,
take risk to create a difference, right, sir?
yeah,
So
you have taken the risk for the country, for the society, and
yes,
it's given me immense pleasure in thanking you for giving a wonderful presentation. I am 100% sure that attendee will be benefited from your talk, and in future, uh, all the participants may contact him whenever you required any type of help in developing drone or
yes, sir.
3D printing or robotics.
Yes, sir.
He and his team are working very good for developing these items like 3D printers, robots, or even drone, flying planes. So
Yes.
I also thanks to all the participants for joining the session. And today you have asked the question. It means uh, the lecture the session was good. I wish all of you a good luck, and we will meet tomorrow at 10:30 a.m. So today's session ends here. Thanks one and all, especially Vyom Singh. Thank you very much. Looking forward to
Sir, I
seeing you
have
on. Yes, Vyom.
Yes, sir. I have shared my email ID in the chat. If anyone would like to contact me, if anyone would like to have any questions, please kindly contact me. I'm available anytime to answer any questions. Thank you.
Right. So I hope all the faculty members who are participants today will send mails or their query on his mail, and back him in growing as an entrepreneur. You kindly extend your support in becoming a successful entrepreneur. He is a very commitment, decent guy, disciplined guy. So definitely we will extend our support to you, Vyom. And thanks once again to you. Thanks everyone. We will meet tomorrow. Tomorrow's session is on bond graph. It is again a technology which is not explored much more in India. And Professor Rastogi will deliver a talk on bond graph, followed by a case study, application of bond graph on railway vibration control, or you can say analysis of vibration of railway. So it is again going to be very interesting, and it will explore the research area for you people. Kindly join tomorrow's session once again. Thank you, one and all. Thanks, Vyom. Thank you very much.